Hi, welcome to my video on given the value of a trig ratio. Find the values of the other 5 trig ratios. And this is part 1. The other part will be in the next video. Part A in this video. Given the value of the trig ratio and the quadrants. Let's do this example. Find the value of the other 5 trig ratios if cos theta is 3/5 in quadrant 1. Well, we have it in quadrant 1, so let's draw the diagram in quadrant 1, x and y. And quadrant 1, cos theta is 3/5. Now, cos is the x over the r. I have a little sheet of paper that I use all the time, but this is only for you that I have memorized. I know it. That SOHCAHTOA is for sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. On a circle, sine is the y over the r, cos is the x over the r, tan is the y over the x because they're opposite, adjacent, and hypotenuse. And cosecant is the r over the y, secant is the r over the x, and cot is the x over y. Notice the reciprocals. So, cos theta is 3/5 is the x over r. So, let's draw a circle, and we'll plot a point. Let's take this point right here. Don't have to be exact. The center of the circle is 0, 0. And x, this point, if we do a terminal arm going out to this point, and we drop a perpendicular to the x-axis, then this is theta, and this is the reference angle, which is also the theta. And so x is 3, and r is 5. That means we have to do r squared is x squared plus y squared, like the Pythagorean. R is 5 being squared. The x is 3 being squared. And so that's 25 equals 9 plus y squared. 25 minus 9 equals y squared. So y squared is 16. So the square root of y squared is plus or minus the square root of 16, which is plus or minus 4. So y comes out to be, and in this case, y is positive. Now, y could also be a negative, depending on the quadrant. But in this case, because it's first quadrant, the y is 4. Now we have the value of y, and we have the value of x. So we have x is 3, y is 4, and the radius is 5. So since we have cos theta is 3/5, reciprocal of cos is secant, cs of the theta is reciprocal, 5/3. The sine of theta is the y over the r, so it's the 4/5. And the cosecant is the reciprocal, which is 5/4. And the tan of theta is the y over the x, so it's 4/3. So cot is the reciprocal, 3/4, or the x over the y. And that's how you work out the values. Just want to mention that this is the rotation for theta. And notice, again, it's in first quadrant, so x's and y's are all positives. Okay, there's one done as an example. Practice means you try this before I do it. Find the values of the 5 trig ratios if sine is a negative 5/13 in quadrant 4. So, what I do again, if you pause your video and you want to work this out before I do. We're in quadrant 4, so this is quadrant 1, quadrant 2, quadrant 3, and this is quadrant 4. So in quadrant 4, we have a point So we'll draw a circle. There it is. Don't have to be exact. Again, this is the x-axis, and that's the y-axis. X is positive on this side, negative over here. Y is positive above, y is negative below. So we have sine of theta is negative 5 over 13. And sine is the opposite over adjacent, so it's the y over the r. So that means if we take a point where we do the terminal arm, here's the terminal arm. Terminal arm is rotating from here. So theta is this rotation all the way around till it gets to that. There it is right there. And I just want to mention, let's go back to this page that I just did. Sorry for that, I forgot to mention it, that after I have this plotted, x is 3 and y is 4. So this point has coordinates of 3, 4 after I derive the x, y, and the radius. And that's the same here. I have a point. So the y coordinate of the point is negative 5. The radius of the circle is 13. So we drop a perpendicular to the x-axis. And we said that the y was negative 5. And we have to find out what x is. So r squared is x squared plus y squared. The radius is 13 being squared. We don't know what x is, but we'll find it. Y is negative 5. 13 squared is 169. X squared. Negative 5 squared is 25. So x squared is 169 minus 25. X squared is 144. So the square root of x squared is plus or minus the square root of 144. So x is plus or minus 12. And in this case, again, we're in quadrant 4, and this x is positive, so x is a plus 12 in this quadrant. So we have x is 12, we have y is, x is 12, y is negative 5, and the radius is 13. So let's find all the trig ratios. We already have sine, negative 5 over 13. So reciprocal of sine is cosecant is, again, 13 over 5, but the fraction is negative, never goes on the bottom. So we'll do cos. The cos is the x over the r, and the x is 12 over the radius is 13. And secant is reciprocal 13 over 12. And the tan of theta is the y over the x, so it's a negative 5 over 12, y over x. And so the cot is, again, reciprocal is 12 over 5, but the negative is always on in the numerator. And again, once you have your triangle drawn, you can say, in relation to the reference angle, even though this is the rotation on this, the rotation all the way around here is theta. Theta is, let's make it not, there's theta. Again, I got to be careful. A quadrant is with a Q, and theta got a stroke going all the way through it. So theta is this rotation all the way around here. And so after you get this triangle, you can say that cos is opposite over hypotenuse. You can say cos is adjacent over hypotenuse. Sine is opposite over hypotenuse. And tan is opposite over adjacent if you want. When you get to, or you can use, again, sine is y over r, cos is x over r, and tan is the y over the x. Your choice. When you get the diagram drawn. And let's do another example. Find the value of the other trig ratios if tan is 3/4 in quadrant 3. Again, we have quadrant 3. Okay, there's x and y. We have quadrant 3, so this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So tan is going to be in this quadrant. So what we'll do, we'll draw a circle. And it's in quadrant 3. So we start right here. And we're doing theta. Theta is the rotation from the initial arm. It's rotating from here all the way around the circle until it hits in quadrant 3. Let's pretend that it hits right there. So the terminal arm goes out through. And this is the rotation of theta right here. Again, notice theta is 90, 180. So theta is between 180 and 270. And we drop a perpendicular to the x-axis. And we have tan theta is 3 over 4. But tan is the y over the x. So the y is 3 and the x is 4. But this is quadrant 3. And in quadrant 3, the x is negative and the y is negative. So the x is negative. There's the x, which is negative 4. There's the y, which is negative 3. So the x is negative 3, the y is negative 4. Even though, because tan is the y over the x, and in quadrant 3, both of them are negative. So when I reverse it, you have 3/4. 3/4 could have been 3 over 4 or negative 3 over negative 4. But in this quadrant, again, the y and the x are negatives. So we do work out the value of the radius. So r squared x is negative 4. The y is negative 3. 16 plus 9. R squared is 25. Square root of r squared is plus minus the square root of 25. So the radius is plus minus 5. Because we have the radius, and the radius is always positive, so the radius is 5. So we have tan. Theta is 3/4. So cot is the reciprocal, which is 4 over 3. And we have sine theta. Sine is the y over the r. Or, again, the reference angle is this angle right here. So sine is the y, which is negative 3 over the hypotenuse. And, or sine is the opposite over the hypotenuse. So the y over the r are opposite over hypotenuse. Reciprocal of sine is cosecant. And we have 5 over 3, but the negative never goes on the bottom. That doesn't say that the hypotenuse or the radius is negative. It's just that the fraction is negative. And we have cos of theta. Cos of the reference angle is the adjacent, which is negative 4 over 5. Or cos on the circle is the x over the r. And the reciprocal of cos is secant theta. And we have 5 over 4, but the negative never goes on the bottom. It's always on the top or in the numerator. And again, notice that this point on this circle, the x is negative 4 and the y is negative 3. X is negative 4 and the y is negative 3. And we have them all done. Again, notice the rotation of theta right around, but we work everything out in relation to the reference angle of the right triangle drawn to the x-axis. And let's continue. Now we have part B. Part B is where we're gonna do the trig ratios. But before we do that, let's do some examples. Find the primary ratios. If secant is 2/3, then the reciprocal of secant, which begins with s, is cos. So the reciprocal is 3 over 2. Reciprocal of cosecant begins with c, so the reciprocal is sine, s. So the reciprocal of is negative 1 over 2 is 2 over 1, or negative 2. Reciprocal of cot is tan. So the reciprocal of theta is a negative 4 over 7. Again, the negative never goes in your denominator. Reciprocal of secant is cos alpha. Reciprocal of 2 over 1 is 1 over 2. Cosecant is sine beta. So the reciprocal is root 2 over 1 is 1 over root 2. But we have to rationalize it. So we multiply denominator by root 2. Root 2 times root 2 is 2. 1 times root 2 is root 2. This is simplified radical. Cot, the reciprocal is tan. And the reciprocal is a negative 3 over root 3. And again, we multiply the top and the bottom by root 3 in order to rationalize it. And we get negative 3 times root 3 is negative 3 root 3. Root 3 times root 3 is root 9, which is 3. The 3's cancel, so I get as a 1 and a 1, so I get a negative root 3. And cosecant begins with S, so the reciprocal is cos. S and C and S. Reciprocal is 12 over 13 and is negative. And cosecant begins with C, so the reciprocal is sine beta. The reciprocal is 2 over root 6, but we got to rationalize it, so it's root 6 over root 6. So it's 2 root 6 over 6. Root 6 times root 6 is 6. And the 2 and the 2 goes once, 2 and the 6 goes 3. So the answer becomes root 6 over 3. So that's every time I get the reciprocal ratios, I change them to the primaries because I know where the primaries are easy to work with the primaries than with the reciprocals. So I always change the reciprocal ratios to the primary ratios and then go to the quadrants and where they're plus and minus, and you'll see all that working. So some examples: find the value of the 5 trig ratios if cosecant is negative 5 over 3 in quadrant 3. So we have quadrant 3. So that's the x and that's the y. Quadrants, again, 1. Keep emphasizing that. So these are the quadrants. This is in quadrant 3. So cosecant. So cosecant theta is negative 5 over 3. Cosecant is the reciprocal of sine, so sine theta is 3 over 5. Negative never goes in your denominator. So sine is the y over the r. So that means now when I draw my circle, there's a circle that I'm going to draw. Extend that down. I have theta is going to the third quadrant. So again, I just illustrate that. Here comes theta all the way around to the third quadrant. We draw a terminal arm going out through. Rotation stops here. That's theta. We drop a perpendicular to the x-axis in quadrant 3. And the y is this value here, which is a negative 3. And the radius is 5. So we have to work out what x is. So r squared is x squared plus y squared. R is 5 being squared. We have to find the x, and the y is the negative 3. 25 x squared. Negative 3 squared is 9. 25 minus 9 is x squared. X squared is 16. So the square root of x squared is plus minus the square root of 16. Square root of x squared is x plus minus 4. So what is the x value? And again, you're in quadrant 3, and the x coordinate is going to be a 4, but that 4 in this quadrant is negative. So x in this quadrant is negative 4. Now remember, x is plus minus 4, but because we're in quadrant 3, then the x is going to be negative 4. So the coordinates of this point is x is negative 4, y is negative 3. And again, everything is determined by the reference angle. The reference angle is this angle right here in this quadrant. So we have cosecant theta is negative 5 over 3. And we know what sine is because we just worked it out, is negative 3 over 5. And we do this cosecant. So now I can do cos. Let's do cos. Cos is the x over the r. So it's a negative 4 over 5. Cos is the x over the r, or cos is the adjacent over the hypotenuse. So that means that cos secant theta is 5 over 4 negative. And we have to do tan. The tan is the y over the x. So tan is negative 3 over negative 4, which is 3/4. So cot is the reciprocal of 3/4, which is 4 over 3. And again, if you're doing tan, tan is the opposite over the adjacent, or the y over the x. And we've worked reciprocal ratios. And the final one on this, we have page 7. Find the value of the other 5 trig ratios if cot theta is a negative 12 over 5 in quadrant 4. Again, always good to draw a diagram. X and y. We're in quadrant 4, and we have cot. So the cot theta is negative 12 over 5. Cot is, well, we can get tan first. Tan is 5 over 12 negative. So tan is the y over the x. So cot is the x over the y. But we're in quadrant 4. So let's plot quadrant 4. And let's do a circle first. Let's extend this out and draw a nice circle. And theta is in quadrant 4, so it's all the way around. That's the rotation for theta. Let's stop right here, don't make any difference. Terminal arm goes out through. We're not worried about where we long as we stop in quadrant 4. So this is the rotation for theta. Again, this is quadrant 1, quadrant 2, quadrant 3, and this is quadrant 4. So we stopped in quadrant 4. And we drop a perpendicular to the x-axis. And it says that the x is 12, negative 12, but don't have to be negative. So the x is 12, and the y is 5. So the x is 12, the y is 5. But in this quadrant, which is quadrant 4, the x is not, even though the negative is with the 12, it could have been as a fraction 12 over negative 5, which turns out to be the negative of 12 over 5. So because the fraction is negative, it's not necessarily that the 12 is negative. The 5 could have been negative. So in this case, it's 12 over negative 5 because the x is positive in quadrant 4, but the y is negative. Just be careful. So r squared is x squared plus y squared. So we're looking for the radius. X is 12 and y is negative 5. So that gives us 144, 25. So it gives us 169. Square root of r squared is plus minus the square root of 169. So r is plus or minus 13. Because it's a radius, which is always positive, we have 13. And so we have cot and tan already done. We got cot is negative 12 over 5. We have tan, which is negative 5 over 12. So this is cot. I better put cot here. I put cos there. So cos of theta. Cos is the x over the r, and the x is 12 over r, which is 13, or the reference angle is this angle right here. Cos is the adjacent over the hypotenuse. And sine, I got cos, so let's go with secant, reciprocal, which is 13 over 12, reciprocal. Sine is the y up over r, so it's the y is negative 5. and r is 13. And the reciprocal of sine is begins with c, so it's cosecant. That begins with s, so this begins with c. Cos begins with c, so the reciprocal is s secant. So the cosecant is reciprocal, which is 13 over 5 negative. The negative never goes in the bottom, even though 13 is the hypotenuse, but the fraction is negative. 13 is not negative. The 5 is the one that's going to be negative in this diagram. And this point right here, x is 12, and y is negative 5. So that's the point that right here, that the terminal arm passes through. So that's working the other way. Where I give you the ratios, you work the other ones out in different quadrants. Good practice. Remember, we keep building through examples. And if you like my video, click on the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.